Nice to meet you, everyone. My name is Noam Levy. I'm the field CTO in GroundCover. GroundCover is an observability company. Anybody here uses any observability solution? Datadog, New Relic, Dynatrace, any one of those solutions? Awesome. So today I'm going to speak about observability and how observability is basically being torn apart by AI. It's taking over all the signals that we as vendors are seeing and also changes the way applications are behaving. APMs, as they are today, are not ready for how agentic workloads are operating. And we're going to dive exactly how APMs are basically breaking due to the new nature of applications. And since humans are gradually being taken out of the software development loop, the only thing we truly left to do is to observe. So that challenge of how we solve observability for the AI era is basically the last challenge that we as engineers have left dealing with in an era where we are not literally writing the software anymore. So you saw my first picture. This is apparently also my picture. I asked Nano Banana to take one of my favorite pictures and just give it a LinkedIn vibe. The prompt was literally, "Hi, please take this picture of mine and turn it into a LinkedIn-worthy picture." Nano Banana thinks it is correct. Everything in terms of the expectation, in terms of the SREs on Google's side, in terms of the user experience, everything is flawless. There are no APIs that return error. The only point where it is clear that this is not a good output is in my mind. Is this a failure? We need to understand how we are ushering an observability world where this is indeed a failure, not a potential failure. Here's another example. So this is a distributed trace. Is anybody here ever worked with tracing before? Saw the beautiful water falls of APIs? Awesome. This entire trace took 3 seconds. This entire transaction took 3 seconds, and it spans across around 10 to 15 spans. 3 seconds API, would everybody here agree that 3 seconds for an API is slow, right? If anybody here will press the buy now button in their favorite shopping app, and it will take 3 to 5 seconds to fully process the purchase, it will be like a sluggish experience. But if this was an AI reasoning procedure and you put an input and you got your exact output, the result that you are looking for in under 3 seconds, you're very happy about it, right? 3 seconds for an accurate result for a one-shot? Awesome, I'll take it any day. So that entire notion of what is slow and what is fast is even changing when we're talking about agentic workloads. And just not too long ago, we were all very happy about having an LLM model in our disposal. Now, we start to see, at least customers and ourselves, when we're building our agentic experience, that we are looking into how each model from the dozens of models that are at our disposal are operating. And there are new models that are being leveraged and implemented at unprecedented rates. So questions about how our software is operating, there is a whole new class of questions about how our software is operating, that the rate of adoption of new technologies into core business applications is something that, from observability perspective, we have never seen before. Agent workflows and agentic workloads are a complex issue. So you saw it, you see it when you are running Cloud Code command, you see it when you're adapting it into your applications. Agents are doing multi-turns, they are leveraging MCP integrations, they are reasoning over the results they are getting. A same input to different models can produce a completely different chain of events, and there is an entire pipeline of retrieving data that is not just MCP that the agent is leveraging. It leverages the web, it leverages your own internal APIs in order to produce the final output. And the entire chain of requests themselves is looking very different than how APIs are behaving. It's like an evolution of what in API, so if people here are familiar with the concept of middleware, so before we are handling an API, we have tiny procedures that are enriching the request before we are handling it by the core logic. Agents have the same issue, but just much more complex. They first, in a lot of enterprise environments, need to understand if they can perform the requested tasks. They have guardrails. They have skills and context that is being enriched by system cards that changes the goal from the initial user input. And there is a whole lot of other levels before there is actual response being generated and sent to the user. The three famous pillars of observability that we've built in the last years and that we each one in a different era are not suitable as is, and we're not taking into account basically that applications are going to behave like humans. There were assumptions about determinism of applications, about a life cycle of a request, that these pillars are no longer accommodating. So basically everything is about to break. Yeah, by the way, this is not one of those talks where I'm going to be very confident about telling you that there are clear solutions and you are all behind in adapting the solution. This is more of like a stressing out together a talk. And hopefully, at least in ground cover, we think we have some ideas about how the future is going to look like adapting this kind of workloads. But to be honest, we are also in the constant re-understanding of what actually things are going to look like. And there are a few things I'm going to show here that, at least internally, we have diverted completely from the initial assumptions that we had. So let's start breaking down how those different pillars of observability are breaking. So logs. This is a classic log example. So we are looking at the level, for example, and we do free text search. Everybody, I assume, are familiar with logs. Logs are like the most archaic pillar of them all. Easiest to adopt, the most polluting one for sure. Volumes in logs, when we're talking about agentic workflows, are officially no longer predictable. This is a big rant, at least we have on observability in the last years, regardless of AI, but that engineers, even when they are writing the code, have zero tooling provided to them to understand how much data signals, how much traces, metrics, and specifically logs, their application is going to generate once it's hit production. Everybody here who vibe coded some change into production. How many of you had in mind when they looked at the result if there was a new log line introduced by the agent? Was this any concern? Was this ever a concern for you where you were looking at an AI generated code? Or did it introduce a metric that potentially will show high cardinality behavior in production? Yeah, nobody looks into this kind of thing. Nobody looks at an agent result and thinking, oh, I wonder how much volume of traffic this is going to generate in production when it comes to observability data. So how we are going to price it, how we can continue use observability solutions that are strictly tied to ingestion-based model and to query model. Like let's say we're doing an MCP integration, there are observability vendors, they're in general or data lake solutions where you are paying per query. You're now integrating that vendor's solution MCP. How many queries are going to be executed by the agent? It's going to be depending on the model. It's going to be depending on the harness, on the framework that the model is being used in. How can we predict pain by query? And what about conventions and continuity? I'm vibe coding using Codex 5.4 since a few hours ago. And my colleagues are using Opus. We are not using a skill that consolidate or give the agent conventions on how we do logging in the code base. Who assures that my agent is not going to introduce a new logging library or is going to structure the log in a slightly different way that it's going to make it much harder to look into data once it hits the observability landscape? I lost track for a second. So what's going to happen to logs in this era? AI has a long living context. So the reasoning can take a minute and it's going to emit different logs during different states. And we are going to vibe code into our applications at unprecedented rate, introducing even more log and modifying existing logs in the applications. The thing that is somewhat comforting in this scenario that logs, unlike the other pillars, are somewhat flexible. So they are going to relax some of the constraint, and we can always, at least you as consumers, can work around some of these challenges because, let's say, at the very least, logs allow you to do like free text search, right? It's very hard for us vendors to accommodate free text search on large timeframes, but that's our problem, not your problem as consumers. So at least we don't have that schema issues, that structuring issues that really slows down development. Let's talk about traces. This is where things are getting more complicated. Less companies are using tracing even today. Hopefully with the maturity of OpenTelemetry, and we, at least from our end, we see that more companies are adopting tracing into their applications. But tracing, with all the power that they provide, have structuring and also assumptions on how trace is going to look like, core assumption. So Groundcover is developing an agent. We're going to release it soon. And this is an example from one of the early prototypes of our agent of the reasoning, how the reasoning procedure look like, including the tools integration behind the scenes. You can see this is a 1 minute trace, dozens of spans in the middle. Every one of them is important to us, especially as we're developing the agent itself. And I think this is a very important point to emphasize. We are all adopting bleeding edge technologies into our core business application. There is no room in when you adopt bleeding edge technologies into application to be blocked by, am I shipping too much data? Is this data point really needed? If this data point is no longer needed, I need to really quickly take it out because it is costly. We can't have these concerns when we need to keep up with companies that are, or with competitors, or even with competitors that are all of a sudden operating at 10x, 100x the velocity that they used to. Traces were not assuming that when traces pillar was created, it's not that we were not planning for 1 minute traces to happen. It just wasn't assumed this is going to be a standard case. And a few examples to show it. And before we will dive into it, here's also an example of one of the early prototypes of our agents, how we thought the general architecture is going to look like. So basically, you have a conductor where we're introducing the initial prompt, and then we are activating specialists depending on the observability use case. Then we do a synthesis process where we combine all the specialist outputs, and then we give a summary to the customer. And of course, we can loop through it. This is the reasoning procedure where we can distill the answer and then show the user the final output. These kind of architectures happening over long periods of time are breaking core assumptions that we had when we, as observability vendors, planned tracing to look like. Traces, agentic workflows are not stateless, right? They have memory. They are taking into account references, and we want to also sometimes cache those references. There are no longer limits to the amount of nodes or spans that can occur in a single trace. Time is not limited. 1 minute traces are not going to be an anomaly in agentic workload. This is going to be a standard case. And most importantly, potentially most importantly, they are not deterministic. A trace with the same input will look drastically different when I'm changing a model, for example. It can literally create a different chain of spans just because I did a very slight tweak on a very soft, in terms of surfaces, a very soft change into one of the surfaces in the agent itself. Another promise in the distributed tracing world that is very unclear how it's going to accommodate new world agentic workflows is tail sampling. So when you're sending traces, and for those of you who are using traces, you're familiar potentially with the concept of sampling. Sending all the traces and sampling all the interactions that applications are doing all the time is very expensive and also not needed. To give you an idea, big enterprises usually sample 1 to 5% from their application traffic into traces and ship them to the observability vendor. 1 to 5% usually is sufficient. Sometimes when you have an outage, you increase it and then pray that the observability overages are not going to bankrupt your company. The big question and the big challenge in tracing world is how do we decide which traces we send home? What makes a trace important? So obviously, naturally, the first kind of traces we want to send back home are going to be the traces that contain an error. We cannot predetermine an error in a trace before we saw through the entire trace. This requires holding a state for a very long time. Now, tail sampling was taking huge amount of resources for a lot of sessions that are taking 2-3 seconds. Imagine like having 10,000 requests per minute and needing to hold a state for 3-4 seconds for all of those traces. What happens when we have 50K spans in a reasoning trace and a session takes few hours or even few minutes, more than a few minutes, where depending on how you abstract a trace session. But if you decided the trace session is a complete user session with the agent, then you're going to have big troubles trying to do tail sampling, to apply tail sampling concept on this. If you do head sampling, which is the other option, is basically just saying, I'm going to probabilistically look at the beginning of traces and take and then potentially you are going to miss out on very important examples. And again, going back to my original claim, when we are adopting agents, we don't have the luxury of not being very in touch with how our traces looks like at the very early days of adoption. Next thing is how about determining if a trace is good or bad. So this head and tail sampling assume that a span will shine, that will make it very clear that there is an error. But as we already discussed, good or bad are not manifested as error spans in agentic workflow. It can be basically hallucinations. And what about privacy? When we're talking about agentic workflows, basically we take user prompts and we let users put whatever they want in that prompt that can potentially also contain a lot of company PII, and we are going to ship it to our observability vendor if we decide that this is belonging on the trace, because the user prompt, in a sense, is a part of the spans that we have to have in order to truly understand if the behavior was good or not. Pricing. So we need all this data and we need a higher sampling rate in order to adapt this in a way that engineers are in touch with how the application is behaving. And if we're paying by ingestion, which is what 90% of the vendors are doing these days, how we are going to predict how much we're going to pay for traces, and how we are going to, if we used to have on each request, let's say 10 spans, now we are going to have workflows that have 200 spans, 1,000 spans on each workload. By the way, if you want to have an idea how much spans as an observability vendor we see in a single trace these days, so we have customers that are, basically we had to increase the limit to 100,000 spans on a single trace in order to accommodate some of new agentic workflow needs. Let that number sink in, 100,000 spans in a single trace. And what about instrumentation? Tracing as a concept is relying on engineers in generating signals within their applications. When applications are being written by agents, who is enforcing instrumentation? Let's take my earlier question. When engineers are not looking into whether new log lines were introduced. Is everybody looked into whether new OTel instrumentation, new OTel spans were introduced when they were factoring an API or added another DB call? Do you think that code reviewers, agentic code reviewers, will identify it? No, because observability orientation is still very early. And in general, we don't want to, by design, rely on an intuition to instrument. We want something that's more agentic. I don't have much more time, so I'm going to speed things up. So what can we do? Again, I don't have all the answers, but I can tell you what we at least believe are going to be unblockers for solidifying solutions that will accommodate agentic workflows for a good long-term observability posture. Anybody here heard about eBPF? Awesome. eBPF is a Linux kernel technology. Basically, we can load into the kernel a program that gives us visibility into other neighboring applications and kernel operations. This allows zero instrumentation. What zero instrumentation means is that we can generate signals without relying on the agents, on engineers to generate those signals, and we have access to all the data. We can create really high fidelity payloads. So you can see here, for example, what we do in ground cover, we started to use eBPF to extract the entire prompts and show you the entire interactions between the application and the machine, not and the LLM, not just the metadata. But you will say, okay, but this is containing, as you said, a lot of sensitive data. How do we accommodate sensitive data? And on maybe as a result also find a solution to pricing. So there is a concept, and a lot of other vendors are also starting to offer this. If you ever heard about ClickHouse, for example, we just did a webinar with them, and they are also launched a recent BYOC offering. Basically, vendors are now offering to host the entire solution within your premise. This basically cut down egress cost by 40% because data never leaves your account, and all of a sudden, all the data lives within your company premise. You still get the SaaS experience, but we are able now as vendors, thanks to new cloud native technologies, to relax a lot of the constraints that are coming with shipping data to a third-party vendor that is not part of your premise. How AI native observability is going to look like? We need to build it for agent interactions. We need to optimize it using methods like BYOC for data abundance. We need as vendors and as consumers, we need to push for solutions that allow us to have all the data points that we need about our applications without worrying about the bill. We need it to run privately because the data that is involved in agentic workflows is very sensitive. And we want this to essentially allow to keep the human out of the loop when it comes to development and remediation. Any questions? Thank you, by the way. Sorry, I rushed the last part. Yeah.
It's been a long time since I had to log the trace, and I remember spans, logging the spans with. So how would this, if I understood it well, there's no orchestration. So how would it work, let's say, within the PHP function?
Awesome. That's a great question. So we just to make sure we're talking about eBPF and how it allows zero instrumentation.
Yes.
So the way eBPF agents work, so if you're going to use any eBPF agent for observability, there are multiple, not just ground cover, that are doing eBPF instrumentation, zero instrumentation today. Basically, you load an application to the same machine that your PHP application is running on. The eBPF program is going to able to identify that running process, your running PHP application, and it's going to load hooks. Those hooks are going to get invoked every time your application is, if not all the functions, specific functions like serving a request or firing a request to a third-party service, and they are going to record that interaction. And depending on the vendor and what the solution they are offering, each one leverages different data from the interaction.
Regardless of the language.
Yeah, regardless of the language. The beauty about network interactions when it comes to applications is that they are not handled by your application code, but they are handled by libraries that have standardized, and it's easy to know where to hook them. So when you're invoking an HTTP request in PHP, it basically leverages a common library that we, as from the eBPF perspective, are able to always hook on regardless of the software runtime.
Interesting.
There's no more questions? I do have one, last one. So I think this is the fullest, dumbest question, but why there's a span? Why we have to manage thousands of span? If this is because there's a span by the reasoning of the model, and yeah, go ahead.
Right.
And if us, the human now have to manage thousands of them, like this is not manageable, right? So now the 2.0 will be like, now we have to query our agents to interpret these traces, for example. Yeah, that's it.
So first of all, it's not a dumb question. I think it's the question that we ask ourselves in the company every week and make sure that we get the same answer also every week. Spans, just to align the conversation, spans are either generated by the libraries that you're leveraging automatically. So like network spans, like calling to a DB. If you're using auto instrumentation, this will be added to the trace without you needing to put spans there. The other kind of spans is the spans that you explicitly state in your code. So you basically, as an application developer, you decide what is worthy of a span, what is a data point that you want to be added on the trace and that you want to time it from beginning to an end. Now, the reason there are potentially thousands of these is because the definition of a trace, when we're talking about interaction between a human and an agent, can be, for example, an entire investigation session, or it can be an accumulation of multiple traces that are all containing the reasoning step, which are not limited. Like you have frameworks that limit the amount of tool calling, but the reasoning steps themselves, depending on the agent that you're using, they can reason for or like even for in 5 minutes reasoning, you can generate thousands of spans. Now, is this human consumable? The answer is 100% no. We need to prepare for observability that allows agent to interact with the data, whether it's through very good MCP tooling or to create in-app agents as vendors that are able to reason over this data. For example, in GroundCover, what we are investing a lot in is query language for traces that agents have that we can tune agents to be very successful in writing good queries over data, and in being able to aggregate over a lot of traces very quickly and very performantly.
Just a question. So practically speaking, with your app, just so I understand, it'll help you trace the data to figure out where you're spending your data the most. So how do you optimize that once you've traced it? What's the next step once you have that information?
So first, it depends on the question that you began with. So if we're talking about a root cause analysis here, then hopefully the agent with this kind of fidelity that you have access to the prompts themselves will be able to tell you, yeah, there is an hallucination involved in this session, hence why it was a not successful session. Or you will be able to take next steps, such like creating a monitor on specific new traits that you identify according to these traces. So for example, let's say I identify that if a flow that potentially looks good is actually a bad reasoning flow, I can ask my agent to, for example, generate a monitor and to create like a proactive alert when the next time this is happening, or to basically use the system and educate the system what is an error in this kind of, what is this type of error.
And just practically speaking, what kind of savings do you have once you layer your software in?
What, sorry?
What kind of savings do you have once you layer the software in? So meaning once you layer it in and you have the sufficiency, what do you actually realistically see as savings, like the net savings? Like
in savings of moving to a posture where
meaning like to reduce the number of errors, to get more efficient answers. What's the like?
Yeah, so basically like there is a big KPI that we discuss a lot in observability that's called MTTR, mean time to resolve.
Yeah.
The idea is, at least when it comes to root cause analysis, is to cut down the time to triage an issue and to remediate it. So, and when we have an era where basically, essentially, companies have right now tons of code that is running that nobody can really vouch for, being able to leverage agents to remediate issues that stemming from code that nobody ever really wrote,
right,
is essential to keep MTTRs low and to make sure that our applications are not basically dying by 1,000 cuts without us noticing.
Got it. Thank you.
Of course.
One more question. Practically speaking, why not take that data and feed it into some kind of a model and then prevent these things when coding?
So it's a continuous thing because our applications themselves are always changing. I would say that as the models, I would say this was the assumption that we're going to tune model using observability data to create like an observability-oriented model. This was, I would say, the assumption that we had few months back or maybe a year back. I think since then, models, LLM became so good that I would tell you that at least what we see in GroundCover, that even trying to optimize too hard on the reasoning layer or on the harness ecosystem is even trying to optimize the prompt for the LLM sometimes do more damage than it actually helps the LLMs, because, and this is LLMs are only going to get better. So I'm not sure if tuning LLMs with retroactive data is what's going to make them good on the long term. It's more about building an agent that can interact with your data and with the entities of the observability solution that you're using, and continuously be able to be successful as you're changing your applications all the time.
So for those who just came, I'm inviting to like our LinkedIn fan page. It's just LLMday. So I'm constantly posting. So if you could share, like, comment, so it boosts visibility of our event. And now we have 1 hour of lunch break. At the back of the room, we have food. So feel free to have some. Thank you.
Do you remember the